Okay, so if I look at this first problem, um, there's something I need to clarify. As I started to do some of these problems, I got thinking about what I had said and I needed to clarify it. So realize this problem, like the first one, it's a random sample of 250 students at a university. Okay, so that 250 students, that's a sample of all the students at that university. So when we talk about this standard deviation, realize that this standard deviation is not of our whole population. And so when we said that we could use a z interval, remember when we talked about z interval, and that was if the standard deviation is known, sigma. Realize this is for the whole population. Okay, so when it says the standard deviation is known, we're talking about the whole population. This standard deviation is of the sample that we have used. So realize what we're doing is we're really taking a small sample and we are making um, approximations, we are making statements about our whole population based off of a sample. So we're using our sample to make statements about the whole population. So that's why we're not able to be exact either, is because we're using just a sample to talk about a whole population. And so that's why we have these confidence intervals, is because we don't know for sure, based off of our sample, where the whole population is going to be. But we're pretty sure for the whole population that our mean will be between these values. So anyways, that was just a thought that I had that I thought I needed to clarify. So anyways, looking at this one, it says we have a random sample of 250 students. Okay, so that's our n. It finds that these students take a mean of 15.8 credit hours, so that's x bar, with the standard deviation, so that's s. So that's the difference between the s and the sigma. The sigma is the whole population, the s is just of the sample. Estimate the mean credit hours taken by a student each quarter using a 90% confidence interval. So 0.90 on our confidence interval. So now we're going to go to our calculator and write this or type this stuff in and get an answer out. So let's go to our calculator. Down here, whoops. So we're going to go stat, test, T interval. And our input is going to be our stats. Our x bar was 15.8. The standard deviation for this group, this sample was 2.3, n was 250, and the confidence level is 0.90. So then we calculate it, and then it gives us our interval, 15.56 to 16.04. So anyways, as I looked through these, that's kind of what I saw as far as mistakes that maybe I didn't teach you real well, and that would make it so these ones that you missed that you thought you did right, you probably did, you just probably used the z interval instead of using the t interval. So anyways, that's what you're going to do on all of these that ask for the upper bound for the confidence interval, and that should help you get these ones right that you were getting wrong before. So same thing with this like sociologist problem. So a sociologist develops a test to measure attitudes toward public transportation. So 37, so that's just, he's using 37 people to make a generalization, a statement about the whole population. Okay, so he's using these guys, these 37 randomly selected people, to make a statement about how people feel about public transportation. So then their mean score is 36.4, standard deviation is 22.3, construct a 95% confidence interval. So on this, again, make sure you're using the T interval. I'm using the mouse to write with right there. So use the T interval, and you should get the right answers this time. So good luck. I hope that helps. And we'll see you in class sooner or later.